Hey everybody, today we're going to talk about a new topic, recursion. We'll start with the official definition of recursion. In computer science, this is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Here's a visual that illustrates this kind of process. So one warning about this, let me just put this to the side because I think that meme is going to be distracting. Okay, there we go. One warning about this is recursion can be an unintuitive concept at first. In other words, you may get confused. So that's okay. If you feel that way, that's normal. Now, here's a roadmap I would recommend is first, I'm going to just talk about the spirit of recursion. We're not going to get too much into the nitty-gritty details of any program coding. And then we're going to see a concrete example probably in the next video. After that, I still don't expect you to get it. So you're going to hear from two other perspectives. I found a couple other resources that I think explain recursion in their own voice, in their own way. And that's really what I'd recommend. It's just lots of repetition. And even if by the end of this week, after hearing all these perspectives, you still don't quite get it, that's also okay. You then have 238 or CSC 238 or whatever data structures class you're going to take, which is going to be another chance to get it. Okay, so let's start with the pre-quiz here. So we've learned one way to iterate using loops. And can you think of another way to have some repetitive code that happens over and over again, but without using loops? All right, so you may want to pause the video to think about that. I'm about to go over the answer. So the answer is to use a function that calls itself repeatedly. So the function in itself calls itself. Let's see that in action here. So here we have a function called say hello, and it prints out hello, right? And then after, inside the function, it calls say hello again. Wow. So what do you think will happen here? Well, it's actually, we're going to basically see an infinite repetition. It's not an infinite loop because there's no loop, but it'll be an infinite amount of repetition happening here because say hello will keep calling itself. I'm going to run it, and I hope this does not actually crash my, oh, oops. Yeah, looks like it is crashing. Uh-oh. Oh. Okay, that was close. Let me try one more time. Let me remove this part for a second, and this should run. Okay, now if I put this back in, there you go. You got that infinite loop happening. Can I stop it? Nope. Let me try to close it before it crashes my browser. There you go. Okay, so this is one example of recursion. Not a great example because it does crash. We'll see later that you want to put something else in here to stop it. It's basically missing something called a base case where it stops the recursion. Okay, all right. So that's an example. But why would we do something like this? So I'm going to give a scenario here to hopefully illustrate the spirit of when you might use a recursive kind of approach. So let's imagine that you are traveling somewhere. You're given an address on the other side of the country, 5000 Forbes Avenue, Pittsburgh, Pennsylvania, and you're starting out in California. How would you find your way there? Now, one condition is you must drive yourself there by car, so you can't take a taxi and whatever, or take a plane. You have to drive yourself there by car, and you cannot use a map, including any software, physical maps or software like Google Maps. It is okay, probably necessary, to ask people for directions along the way. So how would you approach this? Well, here's how I would do it. I would, first of all, here's what I would not do. I wouldn't ask somebody in California, how do you get to 5000 Forbes Avenue, Pittsburgh, Pennsylvania? It's very unlikely that anybody would be able to give me such detailed directions. But what I could do is ask somebody how to get to Pennsylvania. Don't worry about Pittsburgh or the street address, just get me to Pennsylvania. And then I have a higher chance of having a productive conversation with somebody. They might tell me, okay, go down this highway and so on. And then I'll end up in Pennsylvania. Once I'm in Pennsylvania, then I'll repeat the process. I can ask somebody there, how do I get to Pittsburgh? Somebody in Pennsylvania might be able to have a productive conversation with me about that, because it's an easier problem to solve, right? So for them, and then they can guide me to Pittsburgh, and so on. Once I'm in Pittsburgh, then I'll ask somebody how to get to the street address, 5000 Forbes Avenue. So if I were to translate what I just said, that process, into algorithm, here's what I might do. Given my input, which is an address, choose the largest unknown part of it, the destination. Why the largest unknown part of it? Because that's the easiest one. I'm most likely to be able to have a productive conversation with somebody about that. So in the beginning, that's Pennsylvania, right? Then ask for directions how to get to that destination. That's step 2. Step 3, I would travel to that destination. And then step 4 is I'd repeat. So I'd again choose the largest unknown part of it and then ask for directions and so on. Let's illustrate this. So starting out, I'm given 5000 Forbes Avenue, Pittsburgh, Pennsylvania. The largest unknown part of this is Pennsylvania. Ask directions to get to the destinations, to Pennsylvania, basically. Step 3, I'll travel there. So in other words, after executing these steps, I'll go from California and I'll end up somewhere in Pennsylvania. I don't know where I end up, it doesn't matter. The important thing is I just get to Pennsylvania somehow. Then I'll run the same exact steps again. But this time I'm already in Pennsylvania. So step 1, the largest unknown part of this is Pittsburgh. I'll ask for directions how to get to my destination, how to get to Pittsburgh. I'll travel to my destination, and then again, I'll repeat. So suppose I start out here, I'll end up in Pittsburgh somewhere. Okay, great. Then I will repeat. This time I'm in Pittsburgh. So suppose I start out here, I ask for directions, and then let's suppose I end up here, which is 5000 Forbes Avenue. And then again, I actually repeat according to my algorithm. But notice what happens. When I do step 1, the largest unknown part is no longer applicable because all parts are known. So then I can stop. So I hope this kind of reminds you of that image of The Simpsons earlier where you keep zooming in, and you keep doing the same thing at each step. And yet it somehow makes sense. It keeps taking you closer and closer to the solution until you get there, then you stop. Okay, now we're going to take this one step further again we're going to translate this into something that looks closer to code, although it's still not working code, but it's still a pseudocode, right? So I took those, some of the steps 1 through 3, and put it into a function called navigate to destination. And it takes an address as a parameter. What it does is it takes the largest unknown part of the address, asks directions to get to the destination, and then it travels to the destination. One thing that's missing from here is the repeat step, because we want to have repetitive behavior, right? We'll see how to bring that back in shortly. But first, we're going to make one adjustment to this. The largest unknown part of the address, we're going to translate this into instructions that a computer might be able to follow more easily. So one observation is instead of the largest unknown part of the address, we're going to observe that this is actually the rightmost part of the address. So let's look back at our example here. In the very beginning, going back to our algorithm, the full address was this. The largest unknown part of it was Pennsylvania, which is also the rightmost part of it. Once we do follow the instructions and we're in Pennsylvania, the largest unknown part of it is now Pittsburgh, which is still like the rightmost part of whatever is left. That's where I'm getting that from, the rightmost part of the address. Okay, now if we were to execute this function once, if I call navigate to destination, pass in 5000 Forbes Avenue, it takes the rightmost part of the address, asks for directions, travels there. This will basically get us to Pennsylvania, but no further than that. So what we're missing is the repetitive part, where it'll again run the function on Pittsburgh and then the street address and so on. So to get this repetitive behavior, what we're going to do is we're going to modify the address a little bit. So on step 4, once we get to Pennsylvania, we're going to delete that from our address. So we'll remove the rightmost part of the address. And then we'll call navigate to destination again with the new shortened address. This is called a recursive case. So let's pause here and just appreciate what just happened here. Yes, the function calls itself. Now, at this point, it might be somewhat unintuitive. You may not have seen a function like that before. So what we're going to do is walk through this step by step. We're going to draw the function stack diagram to understand all these, what's happening when the function calls itself. So we start out with this, navigate to destination. That's our function call. All right, let me open up a whiteboard here. There you go. Okay, so I'm going to represent this function call as a box. Okay. So navigate to destination gets called, and let's walk through what happens inside of our function here. So step 1, you calculate the destination. So the destination is the rightmost part of the address, right? The rightmost part of the address. Oops. So what's the rightmost part of the address? It's Pennsylvania. And then step 2, 3, you traveled there. Step 4, you're going to remove the rightmost part of the address. So the address becomes 5000 Forbes Avenue, Pittsburgh. Then step 5, you're going to call navigate to destination, and you pass in the address. So within the function, you're calling itself again. Let me put that in red. All right, I'll draw another box here. So we got navigate to destination, but this time we're not passing in the same address. It's a shortened address. The destination, again, is going to be Pittsburgh, the rightmost part of the address. Steps 2 and 3, we travel there. Step 4, you remove the rightmost part of the address. So it becomes 5000 Forbes Avenue. And then, again, on step 5, inside the function, we call the function again. It calls itself. So we call navigate to destination. This time we pass in 5000 Forbes Avenue. And so on. So at each step, you get closer and closer to your destination. The first function call takes you to Pennsylvania. The second function call takes you to Pittsburgh. Now, all the function calls are represented here. So we've got navigate to destination, calls itself, passes in this address, 5000 Forbes Avenue, Pittsburgh. Oops. And then that calls navigate to destination again, removes the right part, passes in 5000 Forbes Avenue. And then, well, this is interesting. It ends up getting called again and passes an empty string. And you actually end up with some kind of error here because now you're trying to navigate to a destination that's an empty string. So that's a bit strange. We'll talk about how to address that shortly. But the important thing to notice here is, well, the problem it gradually approaches the solution with each function call. Okay, so how to deal with this case of how to get this thing to stop? Like, remember in the first example, we saw that when we ran the program, it just was an infinite repetitive thing. It just kept going until the browser crashed. So to deal with that, we'll put this condition here to check if the destination string is empty, then we'll just stop. So then we no longer get to step 5. We don't call the function again. As soon as the string is empty, we stop. That can be a return statement, for example, in C++. There's a special word for this kind of a statement, which is the base case. So now our function stack diagram looks something like this. At the end, you stop. All right. So we've walked through an example that hopefully illustrates the spirit of what recursion is. I'm going to read the definition one more time. Recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Connecting this back to our scenario, getting to 5000 Forbes Avenue, Pittsburgh, Pennsylvania was a huge problem. Getting to 5000 Forbes Avenue, Pittsburgh, Pennsylvania depended on first getting to Pennsylvania. Then getting to Pittsburgh, getting to Pittsburgh depended on our solution to how do we get to Pennsylvania. Then getting to 5000 Forbes Avenue depended on our solution to getting to Pittsburgh, and so on. Now, the important thing is that each step, we ran the exact same function. Whether we were in Pennsylvania or in Pittsburgh or at 5000 Forbes Avenue, we ran the exact same function, which somehow got us to the next step. Okay. A couple other takeaways here. In a recursive function, you'll typically have a base case, which tells you when to stop, and a recursive case, which is the other case where you keep going. You keep calling the function recursively again. All right. So this hopefully illustrates the spirit of recursion. In the next video, you will see a more concrete example where we actually walk through some code.